let's get started. So we're doing maps and plans. Okay. Yo, the quality of this is not the best, but we can kind of see what's going on. You should have seen what it was like in the paper. It's black and white and blurry, but I found this off the internet. This is a map of the Kruger National Park, well, part of the Kruger National Park. Okay. And the questions that we have are going to be based off this map. Let me make it a little bit smaller, actually. All right, there we go. And on the right-hand side here, we have the key for the map. So this is a map of the Kruger Park, and they're going to ask us a whole lot of questions based on this map. Okay, this is a section of the Kruger Park. All right, let's see what they can ask us. Okay, these questions are going to be pretty simple and pretty quick. Oh, by the way, there's also a table here with distances between gates in the Kruger National Park. And this, you sometimes see this table with regards to distances between cities in a country or certain points in an area. So how this works is, for example, if you want to go from the Lower Sabi Gate to the Mopani Gate, all right, you go across on the Lower Sabi area, you go across on that row, and then you go down in the Mopani column, and you'll see over here where they meet is 209. So it's 209 kilometers from the Lower Sabi Gate to the Mopani Gate. That's how this table works. Okay. All right. Let's see. The Kruger National Park is a popular tourist destination. Some information about the park is given below. The speed limits inside the park is 50 kilometers per hour on tar and 40 kilometers per hour on the dirt. The gate times, entrance gates open at 5:30. Camp gates open at 4:30. All gates do close at 6:30. Lindsay, try and log out and log back in again, or try unpin my
I'll tell
profile.
her.
I don't know. Yeah. Number one. Number one, is the Kruger National Park. Sorry. Is the Greater Kruger National Park on the eastern or the western boundary of the Kruger National Park? So let's go up to the map. Is the Greater Kruger National Park, this one, on the eastern or the western boundary of the Kruger National Park? That one. So the Great Kruger National Park is the dark beige, and the Kruger National Park is the light beige. Is it on the western boundary or the eastern boundary? Everyone should be typing in chat. This is real easy, guys. Is it on the western boundary or the eastern boundary? Yes, guys. Yes, yes, yes. East, on the west, eh? On the west. So if you think of a compass, all right, let's put the compass there. We got north at the top, south at the bottom, and then you write the word we. Okay, so west is on the left. Yes, everyone should be saying in the west. So here it is over here on the western parts of the Kruger National Park. So the Greater Kruger is on the western parts. Okay, let's write that in here. 2 marks for that. And this comes from a trick paper. Fantastic. Now, Ludwig enters the park through the gate located northwest of the Crocodile Bridge. The gate located northwest of the Crocodile Bridge, which has no camp. Okay. He travels in an easterly direction until he finally reaches the first camp. Write down the destination that he reaches. Okay, so we're going to start. He enters the park through the gate located northwest of the Crocodile Bridge. Northwest of the Crocodile Bridge. All right, so there's the park. And I don't know if you can see, but these little grids here are the gates. And this is the Crocodile Bridge gate. Okay, so I need a compass on there. You're going from there. That's why you put your compass on it. The point that you're going from has the compass. Okay, so we're going from that point there, and it says he enters the park through the gate located northwest of the Crocodile Bridge. So from that point, we got to go northwest. So I'm going to draw an arrow northwest. Okay, now that's roughly northwest. Okay, So which gate is northwest of the Crocodile Bridge? And he's entering the park. Can you guys see on the map another gate along that line? Yep, it's Paul Kruger. All right, it's this one here. Okay, so he's entering at that gate, which is northwest from this gate, the Crocodile Bridge gate here, northwest from this gate. So I drew a line northwest, and I can see that the Paul Kruger gate is the gate that is northwest of the Crocodile Bridge gate. All right, so he enters the gate there. Okay, then the question says, let's have a look. He travels in an easterly direction until he finally reaches the first camp. Okay, so he travels east from that gate. Okay, so I'm going to draw an arrow going east from that gate until he reaches the first camp. Now, what does a camp look like? If we go up to our key, we can see here that that is what a camp looks like. All right. So if he travels east, the first camp he's going to hit, can you see on the map? What is it? Yes, well done, Skukuza. Okay, so there is the first camp traveling in an easterly direction from that gate. That's the first camp that he's going to get to. Okay, it's the Skukuza. The Skukuza camp. All right, so a little bit of direction kind of question here. Zuza, yeah, close enough. A little bit of direction here. So just remember the point that you're going from is where you put your compass, and then we drew a line northwest. That was the closest gate, the Paul Kruger, and then we drew a line east, and we could see that the first camp he hits when he goes east is the Skukuza camp. So that must be the right one there. Okay, let's put that down. Nice and easy tonight, eh? Nice and easy. All right, Skukuza. Okay, question number 3. Show by calculation that the distance shown on the distance table from Alpen to Lower Sabi is the route via Satara. I don't think we can do this one because we don't have a scale. I don't think we can do this one. We don't have a scale. No scale. Yeah, don't have scale. Let's read the question again. Show by calculation the distance shown on the distance table from Alpen to Lower Sabi is the route via Satara. So if I go down here and I do what they say, that Alpen from Alpen to Lower Sabi. So I need to move this. Whoopsie, not that. We might be able to do it with not that. We might be able to do it without a scale, guys. Let's see. So we need Lower Sabi and we need Alpen. All right, so it's 141 kilometers. Okay. And they say it's via Satara. Oh, okay. We don't need a scale for this. Okay, so there we go. So that they say, according to this table, the distance from Alpen to the Lower Sabi is 141 kilometers. Okay, I hope you can see that there. And then they say from Alpen to Satara. Well, if you see, let's do it like this. What is going on with my pen? Oh, it's doing funny things. Guys, I'm going to have to reset here. Just hang on to your horses. All right, just hang on to your horses. I'm going to have to reset here. Whoa, where are we going? We're going over here. All right, hang on to your horses because my thing is doing funnies here. Let's shut that down. Let's try this again. Sorry, guys. A few technical difficulties. Could be this course has been so long. All right. So think about it like this. We need to go from this point here to this point here. So let's say we're going from Orpin to Lower Sabi, El Sabi, Lower Sabi. All right. And we know, according to the table, that the distance is 141 kilometers. Okay. So we know that this distance here from this point to this point here is 141 kilometers. All right. Now they say, look at the table and prove that this journey from Orpin to Lower Sabi goes via, they said via Satara. All right. So I'm going to take that away and say that we should be going through another point, which is Satara. Okay. There's a way we can actually prove this. All right. Because this table says that from Orpin, all right, to Satara is 48 kilometers. Look over there. So this distance here is 48 kilometers. That's what they say, from Orpin to Satara. Now, do we have Satara on the left? We don't have Satara on the left, but that's okay because we know that the whole distance is 141. Okay, we know that there is a stopping point of Satara along the way because it wouldn't be on the table over here if it wasn't. So you can go from Orpin to Satara, but you can also go from Orpin to Lower Sabi. We can confirm this, I think, if we look at our map, unless I don't think they have it on the whole map. You see, if we had Satara on the left-hand side here, we could confirm it because from Satara to Lower Sabi, that would confirm it. So if we had Satara here, and if we had Satara's information here like this, we could go across from Satara to the Lower Sabi, and where it would meet at the bottom here would tell us there would be a figure down here that would tell us. We don't have Satara in here. So we know that there's a stopover at Satara, and we know you can go all the way to Lower Sabi. And this value is 48, and this value is 141. So yeah, I would say that it's correct. Okay. I would say it's correct because it's a short distance to Satara, which is 48, but it's 141 to Lower Sabi. So I would say, yeah, we can confirm that Satara is on the way to Lower Sabi. Okay, because if you go from Orpin, yeah, I wonder if we can confirm it on the map. There's Satara there. All right, there's Satara there at the top of the map. And we're going from Orpin. See, I don't think it's on this map. There's Lower Sabi here. I just don't know where Orpin is. Oh, there it is. Oh. Yeah. Yeah. You'd have to, right? There's Orpin. There's the camp there. If you go from Orpin to Lower Sabi, you could go through this way and then down to the Lower Sabi. You could go past Talamati. Guys, what do you think? I actually don't agree with it now. I don't think Satara is on the way. Let's check the question again. It says, show by calculation that the distance shown on the distance table from Orpin to Lower Sabi is the route via Satara. But we don't have Satara on the left. The only way we could do it is by looking at the values. So from Orpin to all these other places here along this line, we've got 213, 141, 204. These are pretty big. And then you got Satara, which is 48. So from Orpin to Satara, it's just a very short distance. But why is the 141 have to be to Satara? Why can't it be to Telemati? Is Telemati on this table? No, Telemati isn't even on this table. We're going to have to assume that it does, guys, because it's, like I say here, it's 48 kilometers to Satara and it's 141 to Lower Sabi. A hand went up, then a hand went down. Yeah, they're asking about show by calculation in this table that this distance, 141, that distance from Auckland to Lower Sabi, that 141 there, definitely goes through Satara. They're saying confirm that it must go through Satara. You see, the easiest way to do this would be if we had Satara here on this table. I promise you I didn't cut the table short. If we had Satara here and we had some kind of distance, right, for Satara, like for example, if what would it be? It would be 50, 141, so that's 93. For example, if this was 93 kilometers from Satara to Lower Sabi, we could do it. But I don't have that information, so we're going to have to actually assume. Can't really do it. We don't have Satara on our left-hand side, yeah. Well, I would say yes, but we can't really prove it until we had this number here, which is not really on our table. We can look at the map. So what they're saying is this route, I'll show you on the map here. They're saying show using that distance table that this route here from Auckland to the Lower Sabi is via Satara. There's Satara there at the top. They're saying this route from Auckland to Lower Sabi is via Satara. Well, if we had from Satara to Lower Sabi, we could prove it. If we knew what this was, we could prove it. We know this is 48. We know the whole thing is 141. So if we had this number here, and 48 plus that number equals 141, then we could prove it. Unfortunately, we don't have that Satara on our table, so we couldn't really do it, but I would say yes. I would say yes in this case. I think it is. But yeah, we can't really confirm. I'm sorry, guys. It's a bit frustrating. We don't have Satara. I wonder if we can go to another place. Satara to somewhere else. Oh, no. What if we did Crocodile Bridge to Satara? Crocodile Bridge is the bottom, Satara at the top. Do we have Crocodile Bridge to Satara? No, we don't even have that. That's frustrating. We don't have that on our table. What about Satara to Skukuza? We don't even have that. Oh, guys, I wish we could confirm it, but we can't. I'm going to move on. Don't want to waste too much time on this. All right, so if we knew what this distance was over here, if that was on the table, we could confirm because you just add those two up and they must equal 141 based on the table. But we don't have that in the table, so we can't really confirm. Sorry, guys, that's a bit frustrating. I wonder what the tricks of this yet, what they must have felt like when they were trying to do this question. Oh, we got Satara to Skukuza. Satara, Skukuza. There we go. Okay, cool. Let's try. Let's try, right? No, it's on the wrong side of the table. All right, moving on. Let's check. What else do they have for us? That's frustrating. Question 4. Determine the difference between the number of camps and the caravan sites. Determine the difference between the number of camps and the caravan sites on this map. All right, I'm going to have to zoom out a little bit. In fact, let me just make the drawing a bit smaller. We need to determine the number of camps and the number of caravan sites, and we need to know the difference that includes all of them. All right, so it's a whole lot of counting, guys. Can you see the difference? We're talking about camps, and we're talking about caravan parks on the map. What is the difference between the number of camps and the number of caravan parks. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. I count 10 camps. And we've got 1, 2, 3, 4, 5. I count 5 caravan parks. Yeah. Kazimla, yes, I agree with you. I think it's 5. I think we got 10 camps and 5 caravan parks. So the difference would be subtracting them, and that would give us 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 camps. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, guys, I count 6. I count 6 caravan parks. Sorry. Which means the difference is 4, eh? Yeah, there's 6 caravans. All right, so the difference is 4. Right, so 10 camps and 6 caravan parks, which means the difference in the number has to be 4. Yes, Thunder. Good job. All right, so we'll just write down here 10 minus 6 equals 4. All right, that's the difference. All right, let's have a look. What do we have next? Oh, there we go. Finally, a 6-mark question. Here we go, a 6-mark question. Ludwig left Skukuza at 17:03 and had to be out of the park through the Malelani gate before 18:30 the same day. The distance on the gravel road is the same as the distance on the tarred road. Calculate at what time he would reach the Malelani gate if he used the gravel road. Distance on the gravel road? All right, so we're looking at Skukuza and Malelani gate. Skukuza and Malelani gate. All right, there we go. I wonder if we have. Surely this has got to come from the table. All right, here it is. Okay, we've got to use this table. We need a distance. So we got Malelan. We got Malelan over here. And we've got Skukuza over here. Okay, there we go. We got Malelani and Skukuza. And it's 64 kilometers based on this table. So that's our distance. All right, let's bring that down. Okay, so our distance is 64 kilometers. The distance on the ground, calculate at what time he would reach the gate if he used the gravel road. All right, so we're using the formula distance is equal to speed times time. What speed does he travel? Oh, here we go, guys. There we go. These are the speeds. All right, which one is he using? The distance on the gravel road is the same as the distance on the tarred road. Calculate what time he would reach if he used the gravel road. There we go. That's where we get our speed from. We need a speed. Okay. So we're gonna, and they say the distance is the same, the speed on the gravel road. So that's the one we need, 40 kilometers per hour. Okay. I was wondering, where does the speed come from? Okay. So we got a speed, 40 kilometers per hour. Okay. And we need to work out time. There we go. So when you get a speed equal distance and time question, you got to have you got to have 2 of the 3 things. All right. If you have 2, you can find the third. All right. So we got 2 of the 3. We got distance and speed, but we don't have time. That's what they want us to find out. Will he make it to the gate? All right. So yes, well done, guys. 40 kilometers per hour. So we're going to take the time. Now this is the little diagram that you should remember. Okay, you can use the formula and change the formula around, but if you remember this diagram, you're fine. Speed, sorry. This should be speed equals distance over time. There we go. All right. Speed equals distance over time. So if we want to find time, we've got to put distance over speed. Okay, so time is equal to distance over speed. That's what we need. All right, now we're going to put our values and sub them into the formula. Our distance is 64 kilometers, and our speed is 40 kilometers per hour. Now, the hard part of this question so far has been gathering information. We got a distance from the table that they gave us. We got the speed from the text in the question. And then we got to know which formula to write. So T is equal to D over S. The second most difficult thing here is making sure that your units are correct. You've got to have kilometers there and kilometers here. So if one was meters, you'd have to convert. And then the time that we're going to get out is shown here. It's going to come out as hours. Now, it's not going to come out as hours and minutes. All right, there's two time formats. You got hours and minutes. Okay, and then let me just write this down here. There's two time formats that you guys know and use in math literacy. We got hours and minutes, which can be, for example, 1 hour and 20 minutes. Okay, 1 hour and 20 minutes. That's hours and minutes. All right, then you get decimal hours. And that will be in the format 1, comma, it's a third, so it's 3, 3. All right, 1,33 hours. These two things are the same. One is hours and minutes, and one is in decimal hours. Okay, which format will this formula give us? Which formula will this formula give us? The speed equal distance over time formula. Which format do we get this out? Decimal hours. Yes, it's going to give us, this formula only uses decimal hours. All right. So just remember that. Please, please, please remember that. This formula will spit the answer out as decimal hours. If the question wants hours and minutes, you're going to have to change it. All right. And if the question gives you hours and minutes as a time format, you will have to change it first before using this formula. So please, please, please remember, this formula here uses decimal hours. Very important to remember. So many times I've seen students force hours and minutes into there. It won't work. Or they get the answer out and the question says, give us the answer in hours and minutes. And the answer comes out 1,36 and they write there 1 hour and 36 minutes. No. All right. This formula needs decimal hours and it will give you decimal hours. It works with decimal hours. All right. I can't say that enough. All right. So if we know that, then when this answer comes out, it'll come out in decimal hours. We might need to change it, but let's see what the answer is. Okay. So 64 divided by 40 gives us 1,6. There we go. 1,6 hours. All right. Now, what does the question say? Calculate at what time he will reach the gate. So we actually have to change this into hours and minutes. All right. We need to work with hours and minutes here. All right. Because 6 hours is not hours and minutes format. All right. So what we do is we say, this is the same as 1 hour and 0 and also 0,6 of an hour. All right. But we need that 0,6 to change into minutes. So what do we do with that 0,6? Can anyone tell me what do I do with the 0,6 to change it into minutes? Anybody?
Somebody.
Yes, you got to convert, and like a lot of you are alluding to, we need to multiply by 60. Good. So it's 0,6 of an hour times 60. All right. Let's test this. For example, let me test your knowledge. What is 0,5 of 60 minutes? Yeah, that's right. What is 0,5 of 60 minutes? Anybody tell me, what is 0,5 times 60 minutes? How many minutes is that? Yes. Yo, guys, you got to have fast fingers tonight. All right. Yes, it's 30 minutes, right? So comma 5 of 60 is 30 minutes. But we don't have comma 5. We have comma 6. So it's a little bit above 30. Let's check what it is. All right. So 0, comma 6 times 30. Guys, I made a mistake. It's 0, comma 6 times 60. There we go. 36. All right. There we go. I got a fright there when I saw 18. So it's 1 hours and 36 minutes. Okay. He left the place that he was leaving at 17:05. Will he make it? Is he going to make it? Can you see? He has to be there by 6:30. He leaves at 17:05. He's just going to travel for 1 hour and 36 minutes. Is he going to make it? Can you see? We'll work it out, but can you see by looking at the answers? Is he going to make it? Yes or no? What do you think? No, no, he's not going to make it. No, he's not going to make it. All right. Why is everyone saying he's not going to make it? Well, if you add 1 hour to this, you get 18:05. But we still need to add on 36 minutes. That gives us 18:41. He's not going to make it. Never for the days. All right. Now let's remind ourselves how to use the minutes, hours, minutes, and second button on our calculator to work this out. All right. So we got let's see. So we got to say 17 hours 05 minutes. We don't need to put the seconds plus 1 hour and 36 minutes. What will that give us? 18:41. Not going to make it. Not going to make it. All right, so you can use your calculator to add up time this way, or you can do it bit by bit in this way as well. All right, but clearly he's not going to make it. So you'll have to make the statement, no, he will not make it. He's going to be stuck in the Kruger National Park. All right, he's going to have to sleep in his car or something. I don't know. Poor guy. All right, let's move on. Let's move on. Let's move on. Let's move on. He will not make it. Here we go. Now, matrix, when you do the final papers, you will hardly ever see an individual question based on a probability scenario. All right. But probability is part of the curriculum, but they hardly ever give you a single question that has probability in it. It's just a scenario or contextual question with that is only probability. Because they often only have to put like 10% of the marks go to probability questions, or 5% of the marks. So what they do is they inject probability questions all over the place, right? They sneak them in to all the other topics. So you'll have measurement or finance, and you'll see, oh, what's going on here. All of a sudden, there's a probability question. This is the examiner injecting the 10% of probability questions, probability marks into other topics. Okay, and often it's this topic that gets the probability question. So here we go. There's a table here. It shows the number of employees at South African National Parks, which are in control of Kruger, all right, according to race and employment levels. Okay, so these are the employees according to race and employment levels. So we've got employment level ABC on the left-hand side here. And then we've got the number for each race, and then a total at the end. And we also have a total here at the bottom as well. All right, so we've got two totals. Now, here comes the question. determine the probability. Now, as soon as they say that probability, you know that there's a formula. You need a fraction. The probability will equal. You need a number at the top and a number at the bottom. Okay, remember that. The number at the bottom is the important one. So when they say determine the probability, you need to know the total possible. All right, that goes at the bottom of your fraction. All right. And then you get observed, what you saw or what they're asking. That goes at the top. Okay. All right. Ben, yes, you're too fast for me. So it says determine the probability of randomly selecting an Indian employee from the SANP employee. So an Indian person from all of them. Okay. What is the total possible for all of them? Well, here's the total there. This is why Ben is saying 6 divided by that number. All right. So in our fraction, we need to have 4081. That's the total possible. All the possible people that are employed are 4081. But it says here, what's the probability of one of them being an Indian? Well, if we go down to the Indian column over here, how many Indian employees are there? There are a total of 6. So the top of your fraction needs to have the 6. Okay. So you need to build a fraction for probability. Now, sometimes they can ask you to change it to a percentage or a decimal, or just leave it like that. But that is what they're looking for. They're looking for 2 numbers in the fraction, the top one and the bottom one, and you know what those 2 numbers are. So just be careful. Probability questions can be injected into any topic, but they're often found here in MapWork. Here's another probability question. You ready? Well, let's just write this here quickly. So P is equal to 6 over 4081. What is the probability of getting a colored employee from the total employment of level B? All right, a colored employee from the total employment of level B. What is the fraction? Now, this is a 3-mark question. And you can see that piece of information that we need is not there. Ben can see it. You there, Ben?
Hi, sir. Yes,
How you doing? All right. So what are we going to do, Ben? Where's he? Is he gone?
No, no.
I'm unmuting him, you muting him, or the other way around. One's unmuting and the other one's muting. Sorry, Ben, we're messing you around. Sorry, it's my fault. It's actually Kia that's supposed to do that, but I jumped the gun. Yes, Ben. All right. What do we do?
We first have to find out B. So it's
Yeah,
since the total is 622, we have to minus it from 141 and 80.
very good. So the total colored people in all the parks is 622. We need to find B, so we're going to minus A and C from this. So we're going to say minus the A value, which is 141, and the C value, which is 80. We're going to minus those 2 to get the value for B. So it is 622 minus, guys, don't freak out about the brackets. I just like to use brackets. It helps my brain to compartmentalize. All right, so 401. So this is 401. All right, Ben, so the question is, what's the probability of a colored employee from all the total employees from level B? So what will the fraction be?
It will be 104 over 2,111.
Yes, very good. All right, so it'll be 401 over 2,111. All right, that's probability, guys. It's easy. It's easy, guys. Probability is really easy. You need to find a total. That's an important part, the bottom part of the fraction, what total we're looking at, and then the number that they're talking about in the question just goes on top. All right, nice and easy. Okay, Yo, guys, compared to measurement and finance, this is not so bad. All right. This is another map work question, but I'm not going to do this one. I'm going to go down to a but I just want to show you. So this is another map work question. And they ask the usual map work questions here. Direction, north, south, east, and west. They ask for explaining directions, take a left, turn right, go past this. They ask that question as well. All right. See, they give the general direction, write down the name of the park close, name 2 towns, identify the type of scale used, use a given scale to determine the actual distance. Okay, so you have to measure on the map there. And then look down here, name the road. Joe gives them these directions. Where does it end up? Usual map work questions. Name the lodge near the park run. And look here, another speed equal distance over time. So speed equal distance over time questions often come up in the map work section. All right. And look here, the last one, a probability question. Okay, so probability often gets injected into the section. But let's move on to a diagram here. So this is a diagram of a theater. Okay. Everyone comes into the theater, they sit down on the chairs and they're looking at the stage. All right. So it's a plan view of a theater. All right. And all those little blocks are obviously chairs in the theater. Okay. And they're all numbered and lettered to help people find their tickets and find their seats. All right. The ticket will have a seat number and you have to use this map here to orientate yourself to go and find the seat that you need. So this map will be somewhere in the theater and you take your ticket and you say, I'm D16. Where on earth do I go? And you use this diagram here to help orientate yourself in the theater. All right, let's have a look at question 1. Determine as a percentage the probability of randomly selecting an odd numbered seat for a disabled person from all the seats in the theater. Right, as soon as you see the word probability, we know we need the formula. P is equal to, there's a fraction, we need 2 parts. The bottom one we'll do first. Determine as a percentage of probability of randomly selecting an odd numbered seat for a disabled person from all the seats in the theater. Let's read this again. Determine the percentage of probability of randomly selecting an odd numbered seat for a disabled person from all the seats in the theater. I want to know what the bottom of the fraction is. All the seats in the theater. It's not all the disabled seats. It's all the seats in the theater. Now, sure. This brings me to a very important point that I need to make. You have to count all the seats in this theater. If they're expecting you to count all the seats in this theater, guys, it's going to take a while. How many minutes do we have for this? I'm not talking about in tonight's lesson. I'm talking about in the exam. You've got 3 minutes to complete this. If they're asking you to count all these seats, it could take longer than 3 minutes. So this question is actually going to waste your time a little bit. Just be aware of that. Okay, a 3-mark question only takes 3 minutes. You got to complete this all in 3 minutes. Let's see how we can do, how well we can do. All right. So the top row there, I'm talking about this one. We've got 18 there, and we've got 18 there. Oh gosh, 1 to 18, 1 to 18, and then we've got 1 to 27 at the top over there. So we've got 1 to 18, 1 to 18, and 1 to 27 just in the top row. And we've got to add those little ones there too. Oh my word, guys. All right, I would use the calculator for this. I wouldn't even write it down. I would not write this down in your exam script. I would just use the calculator for this. So let's try it out. I'm going to use brackets. Okay, so the top row, we've got 18 plus 18 plus 27 in the top row. Plus, I'm going to use a bracket again. Next row, I've got 13 plus 24 plus 13. You see, I'm already making mistakes now. This is way too much for 3 marks. Way too much work for 3 marks. You see that? 12 plus 22 plus 12. 11 plus 19 plus 11. And there's a lot of human error that can creep in here. 9 plus 17. Oh, 17 plus 9. 8 plus 14 plus 8. 6 plus 11 plus 6. And then I still got to add on. At the top there, I've got 8 on the left, on the top left, plus 8 on the top right. Sure. It takes forever, 304. All right, we've got a total of 304. The next question is, what is the chance of getting an odd disabled seat in this theater? So then you've got to go to the disabled seats, and they show here at the bottom, the handicap or disabled seats are these black ones here with the white numbers. So an odd one, how many odd ones do we have? We've got 15, there's an odd one. 1 is an odd one, 11 is an odd one, and 15. So there's 4 odd disabled seats out of a total of 304. All right. Now, I don't think that question was very, very fair. Making us count. They should at least give us that number in the question because that takes way too much time. Yeah, but 4 and 22 are the even ones, eh? They only want us to do the odd numbers. Okay. So that's the probability of getting an odd disabled seat out of all the seats in the theater for 3 marks. All right, let's have a look at question 2. Identify the row and seat number for a person who is seated as follows. A row and a seat number. So I want the seat number, the letter and the number for a person in section B, 4th row from the stage, in the middle seat. Section B, 4th row from the stage, middle seat. You guys can have a look. Section B, 4th row from the stage, middle seat. I need a letter and a number, please. A letter and a number, please. Section B, 4th row from the stage, middle seat. Section B, 4th row from the stage, middle seat. What is the letter and the number, please? Find that seat. It needs a letter and a number, like B12, G18. It's section B, 4th row from the stage, middle seat. I think a lot of people are staring at the screen now. Yeah, we've got answers coming in. All right, Jasmine's got a couple options there. Yeah. All right, I'd agree. I'd agree with you guys. Yeah. I've got D10 or 9 or D10 or... So section B, all right, is this section here. 4th row from the stage is this one here. And the middle seat. If you've got 19 numbers, this is very good for remembering median. If you've got 19 numbers, an odd data set, you should find 1 in the middle. All right. So 19, which means you're going to have 9 and 9, and then 1 in the middle. So we go up to 9. It's that one there. It's number 10. Okay, so it's D10. Yes, D10, D10, D10. D10, because we've got 19 numbers. So if it went from 1 to 20, then I would say that seat number 10 or seat number 11 will be in the middle. But because we've got an odd number of seats here, there's only 1 seat in the middle, which is D10. Okay. All right. Yes, very good. All right, let's see what else they have. We need to be wrapping up now. Here we go. Ketumetse is seated in D7 of section A. He has to assist his friend in A11 after the show. Describe the shortest possible path he would follow to reach his friend in A11. So he's in D7 in section A. He has to assist his friend in A11. I'm assuming that's in the same section. both section A. So he's in D7. His friend is in A11. He needs to reach his friend. Describe. You have to use words. So he's in section A. He's in D7. He's here. And his friend is in A. Oh, the only A11, guys, is here in section B. That's the only A11 we have. We've got A6 here and A6 there in section A and C, but we don't have an A11 in section B, so he must be in section B. So when they say describe, you would have to use words. So you could say he needs to stand up, turn left, and travel to the end of the aisle. Okay. Then walk down past row C, B, and A towards the stage. All right. And then walk in front of the stage past seats A1 through to A11. Okay, so that's the quickest way to get to his buddy. So using words like stand up, turn left, go to the end of the aisle. All right. Walk down past rows C, B, and A towards the stage. Turn left at the stage. Walk in the front of the stage past seats A1 all the way through to A11. There's your friend at A11. All right, so you got to use words to help you describe. All right,